I speak 8 languages.
He speaks 8 languages, including Beijing. So he has an
if
appreciation
you,
of dialect.
if you include
So
Beijing, then it would be
it's
9.
9. So, but he's very much, his navel string is very much buried here. He's made his living outside of Barbados, and we really want to welcome you home on crop over weekend. No, not the type of crop over weekend most people would have liked, but thank you so much for giving up your Saturday night in Parma. What's it like there in Parma? What sort of temperature are you having? Is it a nice summer's evening?
It's about 27 degrees right now.
Okay, it's a nice, cool outside. Is no rain or anything like that?
No, it was a nice sunny day, but I think that the maximum temperature today was about 38 or something. It can easily get into the mid 40s here in the summer.
Wow. Okay. So Saif, without further delay, I'm going to turn it over to you. Before Saif gets into his presentation, I just want to give you a little insight. I'll give you that insight. We're going to have the presentation now. Just make notes of your questions. And when we come to that segment, you will raise your hand or put your questions in the chat, and you'll be able to engage Saif directly. So Saif, without further delay, over to you, sir. Thank you.
Thanks. Thank you, Vincent. Hi, everyone. Hope you're all well, and thanks for having me again as a guest. So I hope that you find the presentations that I'm about to make a bit compelling. So what I decided to do, because Vincent intimated this just a few minutes ago, is I wasn't aware that anyone knew of my connection to Barbados. So I thought I would throw in a bit of a personal story, including my connections and history with Barbados, and also the personal story from my side and also of the company, and also give you a bit of history regarding why this technology that we're developing today is relevant. So I hope you find it compelling, and I look forward to taking questions. So I'll just fire up right now and start sharing my screen. Okay, so just a minute. Can anybody see my screen?
Yeah,
hello?
We can see it.
Okay, perfect. So, Sentient Blue and hybrid power systems from 2017 to 2022X. The reason we start in 2017 is because that is when I founded the company here in Parma, Italy. We're actually officially registered with the Parma Chamber of Commerce, or Visura Camerale, as a high-tech innovative startup specializing in aerospace. And our mission statement is effectively to introduce hybrid systems based on microturbine heat engines to the world and become the premier supplier of this type of hybrid system. We are starting in aviation because that's where the core expertise of the group lies. So for us, that's low-hanging fruit. So I'm actually British born, but of Barbadian parents. And on a deeply personal note, because I was a bit of an accident, I happened to come along right when both my parents were in the middle of their education in London. So I was whisked off to my grandparents at the age of 6 months. So the first flight I actually took was as a 6-month-old baby from London to Barbados via the Azores. I want you to hold that thought, because the aircraft that I actually flew on was a Boeing 707, which you don't see any of these days because we've moved on quite a bit. But I grew up in Barbados. I went to Belmont Primary School. I went to St. Giles. And then from there, I went to Lodge School in Barbados between 1976, 1983. And then I left Barbados when I was 17 because I received a scholarship from the royal family in the name of Lord Mountbatten. So I went to international school in New Mexico and studied the International Baccalaureate. And that was the start of the language thing, really, or rather the reinforcement of it. After that, I went to Cornell University in Ithaca, New York, which is one of the Ivy League universities, and I studied mechanical and aerospace engineering. And initially, I had intended to graduate and then go straight into aerospace engineering or aviation, but I got sidetracked when I was there and got quite curious, became quite curious about motorsports. So instead, what happened was I left Cornell spent a bit of time in Montreal doing postgraduate stuff, and then went into motorsports. And that resulted in me leaving Canada at the time, returning to New York briefly, and then moving back to London. While I was in London, I did my PhD in fluid dynamics. Initially, that was being sponsored by Airbus on high lift systems, novel high lift systems, which is basically the configuration that an aircraft wing adopts for takeoff and landing. But after the death of Ayrton Senna on the 1st of May 1994 in San Marino, I realized that the research I was doing was also directly relevant to Formula One motorsports. And given the fact that I felt at the time that that was more exciting, I actually switched the purpose of my research and ended up being sponsored by the Ferrari Formula One team to make the research that I was doing adaptable to Formula One cars. And that ended up basically being the F duct for those of you who are Formula One fans. So Formula One was a bit of fun. So this is an article that was written on me when I was back in 1999, just at the same time I started as the head of the competition fluid dynamics group at the Sauber Formula One team, which is based in the Zurich Oberland area of Switzerland in a town called Hinwil. It's about 32 kilometers southeast of Zurich. And this article was about a personal story and also about what I was trying to do with computational fluid dynamics to improve the performance of Formula One cars at the time. So this is a team photo from 2000. I'm the one, I'm in the third row, fourth from the left. And the gentleman who is in the fourth row, second from the left, is a chap called Jos Capito. He was formerly the head of the Volkswagen High Performance and Motorsports Group. And he's now the technical director at the Williams Formula One team. He's a friend of mine. But it's only in large part because of him that I was able to do the things that I ended up doing at Sauber with regards to computational fluid dynamics, because back then we were really and truly pioneers in many respects, because we were developing not only the technology, but we're also developing the cars at the same time, which is not exactly an ideal situation to be in. Ideally, you want to have a well-developed product and be developing the tools, or you want to be developing the tools and have some kind of time before you apply said tools, before you actually start developing the product. But this is typical Formula One, where you're actually developing tools and the product, namely the car, at the same time. Jos Capito was instrumental in what I was able to achieve with the team back in the year 2000, because he bought into what CFD could do for Formula One car performance. So the reason I'm mentioning Jos is because, you know, no man is an island, no woman is an island, and oftentimes it's really an enabler if you have someone or some people who actually believe in your vision, so that they can enable it and accelerate not only the effectiveness but also the utility of whatever you might be trying to bring to the market or bring into the world. So Formula One for me was quite exciting. I don't find it so much very exciting these days, which is why I'm not in it. But on this page, one of the interesting experiences I had was meeting Frank Bruno, who was former heavyweight champion of the world at the time. And again, I'm going to get deeply personal, because this picture was taken immediately after the qualifying of the 2001 German Grand Prix at the Hockenheimring. And I was in Parc Fermé, near Parc Fermé, sorry, doing my spying, because all the cars were basically there after the qualifying so that they could be scrutinized. And I was walking back to the motorhome for the qualifying debrief, and I saw this gaggle of photographers encircling somebody. I couldn't see who it was because it was the far end of the pit lane. And some of these guys are actually taking photographs while walking backwards with 2 or 3 cameras that clearly were worth, you know, thousands of euros. So I thought, well, whoever that must be, you know, whoever that person is, this must be quite important, because these guys are taking huge risk with the equipment, because at any moment, any one of them could have tripped over with one of the others and gone crashing to the ground. with cameras following quite closely behind. Anyway, the scrimmage kind of opened up a bit, and at the center was basically a black guy. I couldn't see who he was because it was so far away, but I was the lone solitary figure walking the other direction, and he saw me, and he kind of like perked up and was like, "Oh, what's that?" So then he, his step kind of quickened a bit, and he made a beeline for me because he could see that I was dressed in a team uniform. So as he got closer, his pace accelerated even more, and he reached me and extended his hand and says, "Hi, what's your name?" And I say, "I'm Saif." And he said, "Well, I know who you are. It's good to meet you." But then he asked me, he's like, "Do you work in Formula One?" I was like, "Yeah, I'm an aerodynamicist for Sauber." And he says, "My God, that's amazing. You don't see many black people in this world. You're the first black person I've seen all weekend. I'm really proud of you, mate." So he basically, while he was telling me this, was grabbing me by the biceps and shaking me. So I don't know if any of you have ever been shaken by a boxer, far less a heavyweight champion of the world, but the guy, it was clear that he had power. And I thought at that moment, the last thing I would want to do would be to tangle with someone the likes of him. But he then proceeded to give me a huge bear hug, which I never managed to get a picture of. But what ended up happening was this was caught on live TV. So the rest of the weekend, the Grand Prix weekend, I ended up featuring on TV a lot more than I really cared to, simply because at the time I was the only black person, to my knowledge, working in Formula One, and certainly the only black aerodynamicist. So the end of this story is that we were driving home on the Sunday evening after the Grand Prix. And when we hit the German-Swiss border in the team bus, I was fast asleep. So the border control, they were asking everyone for their passports, and I was awakened to produce my passport. And I was really badly awakened by one of the border patrol guards shining a spotlight in my face. So I was scrambling to find my passport, which was in my hand luggage. And the border patrol guard said, "No, I don't need your passport. I saw you on TV. I know who you are." So I never lived that down, because everybody was basically saying I was a movie star after that one. So I never lived that one down for the rest of my days at Sauber. But after Formula One, or over the last 32 years, I also spent quite a bit of time at Airbus, mostly doing wing design and nacelle pylon integration. And these are some of the aircraft that I've worked on. It's unlikely that any of you who have left Barbados and taken a flight that's more than 3 hours or longer, it's unlikely that any of you traveling to North America or to Europe certainly would have been able to travel on an aircraft that I didn't have something to do with. So I've worked on the Airbus A320neo, the Airbus A350. So I did the original wing lofts and CF fluid dynamics analysis for that, as well as the nacelle pylon integration. And I also did quite a lot of work on the flat track fairings. Those are those pods that are on the underside trailing edge of the wing that house the flat deployment mechanisms for the high lift configurations for landing and takeoff, or takeoff and landing rather. And I also worked on the high lift system for the A400M, which is a military airlifter, seen down here in the bottom right corner. After Airbus, I spent quite a bit of time at Rolls-Royce. So I primarily, for the military side, I worked on the F-35B fighter, and I spent most of the time working on the lift fan, which gives this aircraft its vertical short takeoff and landing capability. And also worked on the engine offering, which was a Rolls-Royce General Electric collaboration, which was called the F186 engine. That engine was canceled. One of the first things that the Obama administration did, which was one of the few mistakes that President Obama did, in my opinion. but so be it. I still love him. But moving on, I also worked on the RB211 series of engines, which powers the 757, 767, and 747. Trent 500, which is on the Airbus A340, and some of the other 3 shaft engines, which power anything from the Boeing 777 to the Boeing 787. And last but not least, I also worked on the TP400 turboshaft, which is the engine that powers the Airbus 400M military airlifter. So a bit about Sentient Blue. So this is my next emanation, or the emanation after the working for other people, so to speak. So I got a bit bored with Formula One in my last attempt at working in Formula One, shall we say. And I quit as a senior aerodynamicist at the Haas Ferrari team because it was a bit boring, and you know, why should you work in a job that's boring if you don't have to? So I didn't. So I resigned. And my wife and I, we'd fallen in love with Italy by that time, so we decided to stay. So I'm sitting here in Italy, twiddling my thumbs, doing a bit of kite surfing. And I thought, okay, what am I going to do for a living now? So I founded a company. And I have to admit, it was more an emotional decision at first rather than anything that I thought deeply about. But after I founded the company and set about, getting to grips with this hybrid technology, I realized that I could take advantage of the expertise, both in terms of human expertise and manufacturing capability that is sitting here in what's called Motor Valley. And for those of you who don't know what Motor Valley is, there's an area in Italy that stretches from Modena to around Imola, which is in San Marino, which takes in Modena and Maranello, which is where Ferrari is actually has a presence in Modena, but primarily in Maranello, and also Santa Agata, where Lamborghini is based. And in this area, you find engineers and companies that cater to the design and manufacturing to aerospace standards. And this is exactly where we are, right in the center of Motor Valley. And I think Motor Valley is a bit of a misnomer. It should really be called Aerospace Valley, because motorsports is conducted in terms of the manufacturing exercise, the engineering and the manufacturing exercise. It is actually conducted to aerospace standards as well. So I'm out of Formula One, and I'm now sitting there twiddling my thumbs, deciding what to do. Found the company, and the reason that I founded the company was because an old friend of mine contacted me from California to make me aware of something called Federal Aviation Regulations Part 107. And Part 107 was issued by the Federal Aviation Administration of the United States in response to requests from commercial entities to use UAVs, unmanned aerial vehicles, to execute business cases. In other words, you're going to use a drone to make money. Prior to that, the only two entities in the United States that were allowed to use a drone, according to the law at the time, were the military and hobbyist. You could not, as a company, decide to buy a drone or a fleet of drones and go charge somebody money to do something, take pictures or do surveying, land surveying, or nothing. It was illegal. As of October 2016, it became legal. And immediately, the end users of these drones found that they had a rather persistent and annoying problem. They could only keep them in the air for about 20 minutes at a time with a useful payload of, say, up to 4 kilograms. And this was in fair weather, I'd like to stress. So a nice summer's day, 28, 30 degrees Celsius, or a mild spring day, and you could get this kind of autonomy of 20 minutes with a useful payload. Funny thing happened though, when the winter came and you got these sub-zero temperatures, even if you manage the batteries to the best of your ability, and you tried to conduct the same flight, you found that the flight time decreased by 50%, and there's nothing you could do about it. And the reason for that is because of the nominal energy density of lithium polymer batteries, which is governed by the lithium polymer chemistry. And the second thing, which is quite annoying, is that this energy density is temperature dependent, and heavily so. So as soon as you get to sub-zero temperatures, there's nothing you can do to increase the energy density of a lithium polymer battery. It's just 50% lower than what you would get in comfortable shirt sleeve temperatures. So that means that your drone that was unhappily conducting a flight, as far as the end user was concerned, of 20 minutes, you're now down to 10. And we've had cases where the flights were as little as 7.5 minutes in the middle of a New York winter. So and 80% of the world's drone fleet is afflicted by this issue. So we set about developing a hybrid system, because when I first read Part 107, I realized immediately what the problem was in terms of the autonomy. And I also realized that a hybrid solution was called for. And I realized that microturbines that I've been playing around with for decades was one potential solution. So founded Sentient Blue. Then we came to the attention of Genius New York, which is a New York State funded accelerator for autonomous technologies. And just to give you a bit of history, Central New York area, when I was going to Cornell, was thriving. You had companies, there's like Kodak, Eastman Kodak, Singerlink, who do zero-time simulators for the military and for commercial aircraft companies. You had Corning Glass, Lockheed Martin, General Electric. I mean, it was just booming. And then there was a financial downturn, and a lot of these companies downsized or relocated to other areas of the United States, other areas of the world. So it became economically depressed and fell on hard times. So Governor Andrew Cuomo, he decided that he was going to earmark $1 billion to rejuvenate the area. And of that $1 billion that was earmarked, half of it was dedicated towards autonomous technologies. Land, sea, air, take your pick. That is taken, one of the enablers of that, one of the organizations that is enabling the use of these funds is Genius New York. So we were shortlisted as one of the 5 finalists for Genius New York $1 million investment award in December of 2018. At that point, we were guaranteed an investment of $500,000 US. That was a catalyst for us to found Sentient Blue Technologies, Inc. in 2019. And our primary place of business is in Syracuse, New York, with good reason, because we want to tap into the ecosystem that is Genius New York. And then in April of 2019, we won the $1 million investment award. That allowed us to accelerate what we were doing, and in terms of hiring people, in terms of going and accelerating the engineering activity. One of the things that were a result of that is that we filed our first patent in January of 2021, which has to do with how oil is used in a microturbine. And we consider that to be a unique selling point and certainly an enabler for the technology that we're developing. So since then, we had an awful time with COVID-19. I have to be honest and say that I actually feared that we were going to go under in 2019. But our investors, realizing that we were closer than ever to getting this thing to market, they gave us a cash injection, which allowed us to ride out the COVID-19 pandemic. And I'm happy to say that we've turned a corner, and I'll explain what I mean by that a little bit later in the presentation. But we were able to demonstrate proof of concept on the 14th of March of this year, and we're preparing to go flight testing in the USA with our entry into service customer, BFD Systems, and we're scheduling product deliveries for the first quarter of 2022. So the problem that we're addressing is about 20 minutes, typical flight time, and you can only fly for an average of 30 minutes at a time if you don't have a useful payload. I don't know anyone that would really want to do that if you're trying to conduct a business. But to conduct a 20-minute flight, if you take as given that you want to do this for a typical 8-hour workday, you need about 10 batteries. You need to carry a generator to keep those batteries charged, because you need to land every 20 minutes, swap the batteries out, recharge them, do the battery management and whatnot. You're going to need fuel to run this generator. So it's clunky, the downtime is unproductive, it's expensive, and the solution we're working on is this. So we've got the microgas turbine, which is our core expertise. And we also developed high-speed motor generator units from nothing. So just to give you an idea, we've got a 2-stage device here in this presentation, which is our first product, the Maui 8500 hybrid system. So the stage 1 of the turbine is spinning at 190,000 RPM, and the stage 2 is spinning at 120,000 RPM. And that means that we can shrink the size of the motor generator unit, because all things being equal, the size of a generator can be directly proportional to the shaft speed. So rather than take any compromise and take something off the shelf, we decided we were going to do something from scratch. So our generator actually fits in the palm of a human hand, and it weighs 1.48 kilos, and it makes use of latest rare earth metals. When we started the project in 2017, the quoted efficiency of the MGU, motor generator unit, was 98%. And that efficiency is when you consider the conversion of mechanical energy to electrical energy. Without us doing a thing, just last year before COVID hit, our supplier came to us and said, okay, we need to revise the efficiency. It's now 98%. And that's simply because of advances that have been made in material science. And we're happy to take the extra 2% because it will cascade right through the system, and we will see it in terms of the flight time. So we've got the microgas turbine, we've got the motor generator unit. We also have a power management unit. Power management unit is another bespoke design, and it manages the electrical power from the motor generator unit and from the energy storage array. And for us, the energy storage array is just a fancy name for a smaller installation of lithium polymer batteries and or supercapacitors. So our power management unit, it takes a look at what the demand is from the UAV, and then it uses the energy storage array for peak power demand. So there's up to an extra 7.5 kilowatts available from the ESA. It also uses the ESA for load smoothing. And it does this through a process that's called active rectification. So we're able to vary the turbine speed within certain limits, and you'll still get a constant 50 to 55 volts out at 8.5 kilowatts, or 8.5 kilowatts at 50 to 55 volts. Managing all of this is a FADEC, and FADEC stands for Full Authority Digital Engine Control. And this ensures that our system is operating safely and at peak efficiency at all times. So this is what we're working on to put in the air in September of this year. So as I said before, this is a picture on the left. That's my hand next to a Maui test rig that we fired up in mid-March of this year. So that was 14th of March. And then to date, we generated 4.04 kilowatts of the 8.5 that we claim. And this is because we've got a 16-week test plan that we're running through. And that's 16 weeks duration, not 16 calendar weeks. And test data is very promising. In many respects, we're actually outperforming the predictions that we made. We're in the process of doing some anticipated minor design iterations, nothing major, no showstoppers. And we're happy that the overall design is robust. So happy days for us. So our business model is B2B, business to business. And in this respect, we're targeting commercial, military, and leisure sectors. So this means that we'll take in things like drones being used for infrastructure inspection, package delivery, if you will, border patrol, these kinds of things when you come to the military. And we want to have some fun as well. So this is why we're in the leisure sector. So we plan to at some stage roll out turbines, turbojets, turbofans for the hobby industry. Believe it or not, but there are people out there, fairly high net worth individuals, that have, to date, from our research and customer discovery, have spent up to 150,000 euros on large realistic scale radio control aircraft powered by jet engines. It's a fun market to be in. We want to get into it. Not everything you do has to be all serious and stiff upper lip. So our competition, just to give you an idea of the landscape here, is companies like Saito, which make two-stroke internal combustion engines, UAV turbines. They make fairly large turbines as well for UAVs. Doosan, which do hydrogen fuel cells. They're a Korean company. Then you've got JetCat and AMT. They're existing microturbine companies based in Europe, Germany, and the Netherlands, respectively. And then you've got the big three, Rolls-Royce, General Electric, and Pratt & Whitney. So lithium polymer batteries are also on the competitive landscape as far as we're concerned, but you know, they're always promising new technology. Batteries are always a few years away, but that's not going to happen. Lithium polymer chemistry is what it is, and unless somebody comes along with a different type of matrix to extract power from, we think that lithium polymer batteries will remain with a 1 megajoule per kilogram energy density for at least the foreseeable future. In terms of the biggest competitive threat, we see that as the two-stroke engines, but they're heavy, limited performance, and high vibration, high maintenance costs. And in terms of the turbines, existing turbine manufacturers, we see them as effectively, in some cases, energy in a box, not fit for purpose. And the large turbine manufacturers, they're not present. They're not coming anytime soon. They've got huge overheads, so they're not going to make money in this business due to those overheads that they have to cover. So in terms of our intellectual property, it's a few details about the patent that we filed back in January. And funnily enough, people expect something reasonably exotic sounding when we talk about this, but the patent actually concerns the oil system. And even calling it an oil system is a bit of a misnomer. It really is how we use the oil in the turbine. So contrary to what you might expect, oil in a turbine, whether it's sitting on the wing of a Boeing 777 or an Airbus aircraft or a military aircraft, the primary function of oil in turbines is not actually for lubrication, it's for cooling, and for cooling the bearings in particular. And after that, you get other functions such as cleaning the bearings, and then you get lubrication. And then some microturbine manufacturers, us included, we actually use the oil for damping the bearings so that we can design in force response analysis for how the bearings in response to the various shaft speeds that the turbine might experience. So that is the basis on which we filed our patent, and we see this as an enabler, because the bottom line is that our competitors, or competitors as we see them, they can design a microturbine just as well as we can, if I'm going to try to be humble. But they have some fairly flagrant and persistent design flaws that have been copied rampantly over the last 40 years or so. This is what our patent addresses. So it's an enabler for us. So in terms of addressing the competition, we're going to look at things like product differentiation and make sure that we cover our competitors. Technical support. You know, a lot of you have had the experience where you've called a company because you've got some issue that you need to resolve, and you get automated voice services telling you to push this number, push that number, please stay on the line, your call is important to us. My opinion is that if you are subjected to that kind of customer experience, then your call can't be really important to that company. And as far as I'm concerned, if you call a company because you have an issue as a client or a customer, the first experience that you have should be with another human being interacting with you and directing you to the department that you need to speak to. So that's the way we plan to execute our customer service and customer support. We also plan to understand our competitors and understand the value of their products. And with these things combined, we want to make sure that our customer experience is superior to any of our competitors. So I mentioned the business model earlier. So I said it's B2B. The nominal price for the system is hovering around the 38,000, 40,000 mark at the minute. We're looking, and the price will scale with power. So if you wanted a more powerful hybrid system, you would pay more. And we're targeting, just to give you a bit of a more breakdown, recreational, commercial, military, and research and development companies as well. So in terms of current success, we've got signed contracts and money exchanged with clients in the US and the UK. We have just earlier this year signed an NDA with a large European aerospace company, and we're in the process of discussing what I consider to be quite a large and significant deal for the company with them at the moment. And we've got other undisclosed clients in Europe. And the reason they're undisclosed is because they want to keep a lid on what they're doing, so that they don't want to signal to their competitors that they're moving to hybrid. One of those clients was interested in up to 40 units for this year, the first year of production alone, which will be 2022. And what we've seen, I'm happy to say, is that the interest in the company and its technology has increased since we demonstrated and publicized the proof of concept. So in terms of marketing strategy, in the next few months, you'll be seeing us pop up in these various spaces. We'll be at AUVSI in spirit in a couple of weeks. I say in spirit because the US has got a travel ban on the Schengen area at the moment. So nobody from the Schengen area, of which Italy is a part, is allowed to travel to the United States because of the COVID-19 pandemic. So we expect to be dealing with this for quite some time. But what we're doing is we're arranging through some of our customers and partners to be able to have a display there. And quite a few people know who we are by now, but with the help of our friends, according to John Lennon, we're going to try to, to put on a good show in AUVSI. But we expect to be at Farnborough, Paris Air Show, Dubai International Air Show in the coming years. So we've got code names for our products, which are inspired by the whale, the cetacean species, for the next few years, and then some. So we're actually working on orca and beluga at the moment as well. But the Project Grey, Omura, Blue, and Bowhead, they haven't been taken up yet. But, you know, cross fingers. You know, there are a lot of things that are quite unexpected in life. So we hope that we can take these code names up as soon as possible, because it would mean that the company is thriving. But we're not, in the process of introducing this technology, we're also building a brand, which I'm very keen to do, which is something that I tried to start doing from the day the company was founded. And just in case, because I don't think I mentioned this before, but I actually designed the company logo myself. So I'm very, very conscious of brand building, not only in terms of the logo, but the colors we use, the fact that those colors are used religiously when we do our company presentations, things like this. So going forward, this is the sector. These are the sectors that we would like to go into. We're going to start with drones that are 25 kilograms or heavier, and the market potential for that is $25 billion US. The current opportunity in the defense sector is larger, but that's not the immediate focus, because it takes a reasonably long time to procure defense contracts. But once you've got them, they endure. But it's easier to get commercial contracts, and they can be somewhat skittish, especially in a novel industry, because, you know, let's face it, companies will try and they might not necessarily get their business plan right, or they may not execute it properly, and they fail. And, you know, that's just a fact of life. So be that as it may, we're targeting the commercial sector for our entry into the market. And there you'll see that of the 25 billion, you've got 11.3 billion in construction, agriculture is another 8.5. Then you've got safety and protection, 3.2 billion. Offshore oil and gas, which we're going to be going into, is another 1.2. So you can see it's quite a big market space. So then we will be looking towards the future, but we always are. We've always got one eye on the future, and we're looking to diversify our offerings through different engine models and power outputs. We're looking to increase market share in aviation. We've had inquiries about distributed package power, meaning land-based power, because right now that's mostly being done through the use of clunky, heavy internal combustion diesel engines. We can generate, you know, up to 200 kilowatts in something that would fit into a 28-inch suitcase and could be lifted by your 99th percentile female. Now, before anybody thinks that I'm discriminating sexually, I'm not. The European standards for manual labor in the workplace are based on a 99th percentile European woman. And that basically states that two 95th percentile, excuse me, two 95th percentile European women should be able to lift 44 kilograms together without any kind of assistance from a machine. So that's where this 28-inch suitcase and the weight comes from. We've also had inquiries about marine applications, again, for autonomous technology and manned technologies. And then there's ground transport and racing. Some companies have approached us. We've done concept study for a German company. They're quite keen to put a 200 kilowatt system into goods lorries, heavy goods lorries, trucks, and buses. And in terms of the diversity in fuels, we've had inquiries about burning hydrogen, compressed liquid natural gas, liquefied natural gas, and just for a lark, because we do have some fun in doing all of this serious stuff, we've actually run a micro turbine on virgin olive oil. Now, even when we're joking around, there is some serious side to it. The reason that we did this was because in fulfilling requests for information from certain non-government organizations, NGOs and whatnot, about whether we could produce package power, lightweight package power, they said, can you burn, is it fuel diverse? Is it fuel agnostic? So we said, well, what exactly are you driving at? And it was simply this. I don't know how many of you remember the tsunami that hit Indonesia and in particular the Aceh province in 2005. But NATO forces were instrumental in the relief effort. And what that entailed was sending aircraft and ships in that order to the area as soon as possible with relief packages. And relief packages would basically be fuel, medicine, food, and medical teams. But most medical teams that I'm aware of, they would prefer to have some sort of electrical supply so that they could, you know, engage in the activity of saving lives. And to produce electricity, you need a generator of some sort if you want to do it over a period of time. Generators need fuel. So these relief efforts would have to ship relief packages that included a critical consignment of fuel, because the idea was that you could start your relief effort immediately. Then you would start to clear the infrastructure, meaning the roads, down telephone poles, down trees and whatnot. Airport runways might need the instrument landing system repaired, might need to be cleared of debris as well. Then you would basically get supplies of fuel coming in by air. The assumption would be that the seaports would have been affected in some way, so they would need to be brought back up to an operating status, and then the ships could come in with more fuel, tankers and whatnot. But until that happened, until you were able to do that, you needed to have fuel. And you were only able to ship so much diesel to these disaster areas. So the idea was, can you burn some kind of oil that is readily available? So the answer was, well, we'll see. So in Indonesia, for example, you have palm oil and coconut oil that are readily available because they're a staple part of the diet. And at the time, we realized, well, olive oil is right in that calorific bracket, so let's give it a whirl. So you can burn it. You can run a turbine on olive oil, and by extension, you could potentially also run one on coconut oil or palm oil. And what that does is it expands what you're able to do in the immediate hours or days of a disaster relief effort, because you're not so dependent on processed fuels that have been produced through fractional distillation, which requires a huge infrastructure and, you know, certain standards. Turbines are very diverse and very robust in terms of what they can burn. I often tell people that if you can put a match to it, you can burn it in a turbine. So milestones for this year for Sentient Blue. We're looking to go flight testing in the September-October timeframe of this year, and we'll be supporting that effort from our Syracuse, New York office. You might think that I have a time machine going on here because AUVSI Exponential is actually in August, but the flight testing is in October, so forgive me. And we're looking to sign 6 entry into service customers this year as well. We're on track to do that. Customer deliveries in 2021. And the next steps for us, which is continual next step, really get the message out. We're always trying to do that. And we're also on track to get 7 million euros worth of investment in the company and continue our networking effort in our goals to, again, get the message out, but also to seek additional partners and clients. Now, you might say, okay, this is about Sentient Blue, but why on earth are you doing this? Is there a history to this? Did you invent all of this technology? Is it completely novel? And the answer is no. So, unless there are any questions, I'd like to jump right into this second presentation, which has directly to do, or it is more focused on the mission statement for this particular presentation today. Okay, perfect. Sorry about that. So this was a presentation that I gave in 2019 at the New Air Symposium. So New Air Alliance is a company that is a part of the Genius New York ecosystem. They're based in Syracuse, New York, and Rome. And the Rome location is where Griffiths International Airport is located. Griffiths International Airport was formerly Griffiths Air Force Base, which was a strategic air command base that was home to the B-52, one of the B-52 U.S. Air Force B-52 nuclear air forces. It was closed in the early 1990s, I believe, if memory serves. And that was one of the triggers for the economic depression of central New York, along with the other companies that I mentioned before. So even though I gave this presentation back in 2019, I thought it was very relevant to what we were discussing today in terms of new and emerging technologies. We consider New Air Alliance to be a partner. They're part of the Genius New York ecosystem, and they are one of the organizations in the United States that is partnered with the Federal Aviation Administration in that they run and they oversee a UAV testing facility that covers quite a big part of central New York and is an airspace where you will see that UAV flights are conducted simultaneously in the same airspace as manned aircraft, and they're managed by air traffic control simultaneously. And the reason for the existence of New Air Alliance is to do the testing and set the standards so that the FAA can make unmanned and manned flights using the same airspace a reality as quickly as possible. So here we are with the $1 million check on the night of the 9th of April, 2019. And this is what the use of drones looked like in the United States before Part 107. So on the left, you've got typical drone that you could buy online or from a store, Radio Shack, Amazon, or what have you, DJI. And on the right, you've got a Reaper drone made by General Dynamics. You would not want to be on the business end of one of these things, I can assure you. And this is what it looked like after October of 2016. You basically had a proliferation of all types of drones, various shapes and sizes and mission statements. So the market just exploded, literally, you know, overnight for all intents and purposes. And on the left, we've got the incumbent candidate, which is lithium polymer battery. On the right, we've got hybrid systems, the likes of which we're developing. And there are other offerings in there as well, like hydrogen fuel cells and internal combustion two-stroke engines driving much heavier generators. So in terms of technical progress, since we met with the FAA in October 2019, we've gone from concept to program announcements, design iterations, the laboratory tests, flight tests are coming up soon. And product certification program and delivery, that depends on what type of drone we're installed in. But we have been in conversations primarily with the FAA, to a lesser extent with EASA. And the FAA have assured us that they have an ongoing conversation with EASA regarding this. And given the fact that we're going to start our certification effort in the United States, it makes sense that we would ask the FIA for an introduction to EASA so that we can make the efficient use of those relationships. So we started growing the team simultaneously in Italy and the US. Formally engaged with the FAA, initial contact made with EASA, and we're in the testing phase at the moment, properly in the testing and development phase, with a view to starting deliveries in the beginning of 2022. So, hybrid. Did I invent the hybrid energy concept or hybrid power concept? Absolutely not. Can any of you hazard a guess on how far back this goes? The first individual or company that I can find that actually tried to put a hybrid system into use? Well, it was back in 1900. And this is the car in this picture, and it is a car, but I know it doesn't look like one, is the Lerner Porsche Electromobile. And it was developed and offered for sale between 1900 to 1905. And they actually exported one of these things to the United Kingdom. And back then it was categorized as a horseless carriage. And just to put things into context, it developed a power of 7.45 kilowatts to 10.43 kilowatts. And our system develops 8.5 kilowatts constant to 16 kilowatts peak. So I think that puts things into context. It weighed in at 1,500 kilos. And the power to weight ratio was 0.0069 kilowatts per kilogram. And it was driven by 2 or 4 hub-mounted electric motors and driven by purely battery or petrol engine. So let's jump to the future, shall we? This car was developed by some close friends of mine. Developed and made, I should say, designed and made by some close friends of mine. And I actually did a stint at Audi Sport as an aerodynamicist over the course of 3 years, which was fun. So this is a Le Mans Prototype 1 car, and it's an LMP1H, the H standing for hybrid. So this is the Audi R18, which was fielded in 2018. It develops 670 kilowatts and 900 horsepower, and the weight is 870 kilos. So right away, you've got a power to weight ratio of 0.77 kilowatts per kilogram. So let me remind you what the Electromobile was coming in at, 0.0069. So in just over 100 years, you've gone from the Electromobile to this. So introducing hybrid at Le Mans completely changed the game. If you're just going there in LMP1 with an internal combustion engine, you don't really have a chance at winning. It's just as simple as that. So if you jump across the fence to your neighbor, which is in Formula One, this is the Mercedes W8 F1 car, in this picture being driven by Lewis Hamilton. Love him to death. And this is in Formula One. So Formula One engines developing 750 kilowatts, or just over 1,000 horsepower. And the weight of an F1 car is 728 kilos. So that, for the first time, you get a power to weight ratio of in excess of 1, or in excess of unity, at 1.03. I should tell you, by the way, that Formula One cars have put on about more than 200 kilos since I started Formula One in 1999. So I don't agree with it. I think a race car should be light and nimble, but that's just me. So when I started going to university, the efficiency of an internal combustion engine was about 25 to 33%, but it never exceeded 33%. These days, you get cars like the Toyota Prius, they're maybe around 35%, but in Formula One and in motorsports in general, the top tier of motorsports, basically Le Mans Prototype 1 hybrid and Formula One, the efficiency of that engine back then in a W08 was 52%, which was unthinkable when I was doing my bachelor's degree at Cornell. They've since then improved on this. It's hovering just below 60. And not only Mercedes, but Honda certainly are hovering around that mark. Ferrari can't be far behind. Renault as well. So what does this have to do with aviation? Well, let me first explain to you where aviation has come from in the time that I've been, shall we say, aware. So I mentioned to you in the previous presentation that I was flown as a child from London to Barbados via the Azores on a Boeing 707. And the Boeing 707 sits about here in terms of propulsive efficiency, which is about 50%, and in terms of overall efficiency, which is about 40%. In terms of motor thermodynamic efficiency, which is about 45%. In terms of the overall efficiency, is probably hovering around maybe 23. If you extrapolate or interpolate, excuse me, between the 20% isocurve and the 30% isocurve. Since the 1960s, and just to put this into context, I'm 55 years old. So any of you who are in that age bracket would have remembered Pan Am, BWIA when they did exist. I miss them. BWI when they existed, Pan Am, American Airlines. Lots of airlines used to send 707s regularly to Barbados. And that is a 4-engine low bypass turbofan. It sits here. Since then, we've climbed this way to the point where we're here at the moment. So in the space of roughly 40 years, we've gone from engines and aircraft that are 20% efficient to 40% efficient. And this improvement is the reason why Qantas could fly a twin-engine Boeing 787-900 direct from Sydney to Barbados just 2 weeks ago. And in a similar vein, it's why they could fly from Barbados to Bangladesh direct because of these types of improvements in efficiency all across the board. So over here, again, you see a similar kind of chart. So the 707 would have started here where my mouse is circling around, hovering, and we followed that trajectory. And it's expected that we're going to basically see super linear improvements. So we're going to come off of this curve and go up here and continue a trend up here. What we're trying to do at Sentient Blue is to try to combine the best of both worlds in terms of my career experience and in terms of the technologies that are available in the aerospace industry and in the motorsports industry. So on the one hand, I got the idea of a hybrid concept from my experience in motorsports, having dealt or been the beneficiary of hybrid power plants for some years while I was working Formula One. But on the other hand, I also have a huge amount of experience in the aerospace industry and particularly in commercial and military aviation. So I borrowed things from there as well. And what that basically resulted in was to get a lightweight, compact power system that doesn't compromise in any way, shape, or form in terms of the technologies that you introduce into it, with the sole view of groundbreaking performance. And you're basically going to deploy that first and foremost into the unmanned aviation world. And then after you've established a beachhead there, then you can basically roll it out into other marketplaces. So this is what I was referring to in the previous presentation as well. So you've got lithium polymer on the left, the incumbent. And then on the right, you've got the benefits of what would be a turbine, hybrid microturbine system. So you're going from a worst case scenario of 7.5 to 10 minutes of flight time in the winter to a guaranteed 2 hours to 2.5 hours of flight time, regardless of what time of year it is, regardless of what the ambient temperature is. As a matter of fact, when the temperature drops to sub-zero, the turbine actually becomes more efficient. And we're leveraging, I was making reference before to the 1 megajoule per kilogram energy density of lithium polymer batteries. We're leveraging off an energy density that is conservatively 45 megajoules per kilogram when we're burning heavy fossil fuels like diesel, jet A1, kerosene, or biofuels. And we're temperature independent in regard to how the ambient temperature affects our performance. It does not degrade our performance. And as I hinted at earlier, a drop in temperature actually improves our performance. And last but not least, you compare an 80-minute recharge time to a 5-minute refuel time. We need about 7.5 kilos of fuel for a 2.5 hour flight, depending on the payload. And it only takes about 5 minutes to refuel and get back in the air again. So where are we going with this? Where's the future? Well, on the left, you see line of sight operations, and that covers hobbyist sports, real estate, things like this. Then you've got beyond visual line of sight operations, or BVLOS. The future is here now because the FAA has been granting certificates, operating certificates to various companies like Amazon in the US to do beyond visual line of sight operations with drones. That means you don't have to see the drone. You can basically do the flight planning, launch it, it goes out of sight, lands autonomously at the destination, and can return to you in a similar fashion. So in this Venn diagram, you see that there are a couple of mission statements that sit squarely, are shared by both of these, LOS and BVLOS. And these are things like precision agriculture, structure inspection, mapping, cinematography, first responders, and environmental research. We're agnostic, obviously, with the types of products that we would like to offer, but obviously we're prosecuting a business case. So we're going to first address the ones that we think would make the company profitable as soon as and as quickly as we can. So this is why we're, as they say in the United States, we're skating to where the hockey puck is going to be. So we're focused squarely on BVLOS operations. And once we cover that, then anything else will be, relatively speaking, a walk in the park. So just to give you an idea of the size of some of these units that we've been playing with, in the left picture, that's a friend of mine, Jenny, and she's holding one of the units that we were testing. And that's me holding it in my left hand. We've moved on from since then, and to the type of installation that we would like to see or is possible. which is shown in a drone that we've designed, which is meant for long range endurance and monitoring. So you could do things like fisheries monitoring, border patrol, these kinds of things. Forest monitoring, so that you can detect forest fires quickly and put them out before they cause widespread damage. So that's the kind of mission statement that we have our eye on. That's the kind of mission statement that our technology would enable. So we encapsulate it in a statement: fly longer when you need and fly farther if you want, hashtag BVLOS. So that's it. Thanks for your kind attention.
Wow. So that is a lot to take in a short period of time. And I think for those who certainly do are hobbyists slash businessmen in the drone area, and I'm speaking particularly at this point in time to Dave, who's our sponsor for today.
Thank you, Dave.
I think that would be quite, I mean, for us all really, because obviously I am in construction. I can see Paula, who is electrical, and she obviously is dealing with the health sector at this point in time of her career progression. She's the director of engineering at the QEH, Saif, just to let you know.
Okay.
So in terms
I have an interest in everything, Vincent.
That's right. That's right. But I mean, the application or potential application for the technology is actually phenomenal. Yes. And particularly for our neck of the woods, in terms of disaster relief and these type of things, when you mentioned that earlier, I think that's something that kind of hits home somewhat, and especially recently when we had the little hurricane passing through here. Yes. And the potential for what that could mean going forward in the future is quite interesting. So
yeah, we're actually quite keen on that particular type of project, and we're working on putting together a platform that is geared directly at disaster relief. And you know, the fact of the matter is that Barbados is blessed in many ways, but it's also blessed particularly in its geographic location. And in terms of its geographic location, Barbados is uniquely placed to conduct disaster relief missions for the rest of the Eastern Caribbean.
Yeah. So what I want to do at this stage, we're into our question and answer segment. Saif, as I said quite earlier, is quite personable, quite down to earth. He'll answer your questions to the best of his ability. And I would like to open up the forum at this point in time to receive questions. I have some questions on standby. If it is that you are afraid for whatever reason, or you're not in a position where you can speak, maybe you're in an area that may be noisy at this point in time, you want to post your question in the chat, please do that and I can ask the question. So to start the ball rolling, David, I see you have your hand up. Are you going to start the ball rolling with a question for us, sir? All right, well, go ahead and ask. Yep, go ahead and ask.
Hi, guys. First thing I would like to say, it's been a pleasure to be the sponsor of this meeting here today. Secondly, I would like to say, when are you moving your project to Barbados? Because as you said, Barbados is uniquely poised to be able to not only benefit from your technology, but also to be a location for VTOL and BVLOS right through the entire Caribbean. So a test platform in Barbados would be very strategic for you. And I guess we can talk later as it relates to that. Vincent can put us on or in touch.
Yeah, please. And, please feel free to get my number and email from Vincent.
Yes, it would be great to hook up, because there are so many options and opportunities. Just think about it for 1 minute in terms of the construction sites. As you know, we do quite a bit of construction progression. Yep. And if you have a unit that is BVLOS, beyond line of sight, or BLOS, right? You imagine being able to take off one day and conduct a single flight and take into consideration all the different locations across the island, land, and disseminate that information with a click along with reporting, assessment, and such using photogrammetry and the ability to produce orthomosaics and 3D rendering. That in itself is amazing. The possibilities for maritime use with such technologies and prolonged flight times is also good. And to be quite honest, so far, from what you're telling me, the price points aren't that bad because a 4 to 6 hour VTOL UAV, fixed wing UAV, in other words, aircraft for those others, you'll get for 4 to 6 hours is going to charge you maybe $150,000 to $170,000, not including the payloads.
What?
So yes, it's an investment, but obviously where your future is poised in that Venn diagram middle section, it will offer a lot of opportunities right down the center and take care of many of those aspects.
Yeah. So
Go ahead.
So let me say that, you know, what you're saying is music to my ears. I do have, despite leaving Barbados when I was 17, I do have a very strong emotional attachment to Barbados still. Allied to that is the fact that I think that Barbados has underperformed in many respects since I have had a consciousness, and it's, to be honest, not really a source of pride for me. Got one of the best education systems in the world, one of the highest literacy rates in the world, and to date, no one company that I'm aware of has even come close to scratching the surface of using that potential. Autonomous technologies and the fact that Barbados is blessed with an amazing geographic position is presenting Barbados with an opportunity that has so far gone unutilized. And it's there for the taking. And it will be for many years to come, despite the fact that Barbados may not really want to avail itself of that potential. If Barbados does nothing for the next 10 years, and then after 10 years, it decides to wake up one day and avail itself of autonomous technologies, it will still be able to do something by virtue of its geographic position. And that is a type of blessing that's a type of blessing that doesn't come along very often.
No, what I can tell you is that I do play a pivotal role in consultancies with civil aviation here in Barbados.
Okay.
Right? We are looking at the BLOS option, the online sight, visual line of sight options. It's just that we need to crawl before we run. And some of the issues that we have here in Barbados for lower level flights, you don't necessarily have in Italy and in the United States.
What issues do you have?
Barbadians love to fly kites, my friend.
Up
to
yes.
1,700 feet. Okay.
Yes. You mean like these guys?
Yeah. Oh, look at you. Look.
I made those for my boys last Easter.
Excellent, excellent. So I myself have been privy to a 1,500 foot flight with authority from civil aviation, and lo and behold, but okay. So, you know, it does have its challenges, but getting back to the technology and engineering, as it were, phenomenal. I like the idea of the consistency of the energy, utilizing the battery packs and so on. But my question for UAVs, especially in cinematography and high definition photography, is the vibration. How you propose to reduce or keep the vibrations in a turbine to such a minimum that oscillation is not passed on into the camera itself?
So turbines, by their very nature, are very low vibration, and we balance our turbines to the ISO 2.5, G 2.5 to G 6.3 standard. So this is the same standard that you would balance a high-speed dental instrument to. Okay. So you would never see vibrations at the camera level. You could never achieve that with a two-stroke hybrid system, by the way.
No, I'm pretty aware. I've tried messing with some of them because I am an avid hobbyist in aviation as well.
Yes.
So I fly several planes and have gone through all the wing designs and so on.
Okay.
So yeah, I have a general interest, not multi-rotor alone.
We definitely need to talk.
fixed wing. Right. So thank you for that. I'll put
That is very interesting. All right, so thank you so very much, Saif, and I'll give you your proper title as we close,
What's
Dr.
that?
Akanni. Thank you
Oh,
so much
well,
for
my wife might take a issue with that, but thank you. It's been a pleasure.
Thank you so much for your insightful and certainly intriguing presentation this afternoon. I think it's given all of us who were able to attend the opportunity to really see what is coming and to, I guess, feel a sense of pride as well to know that another Barbadian just like us is out there in the world doing amazing things.
Thanks.
And I think that that's very important, especially for some of the younger engineers who are in this forum this afternoon, to see that do not be trapped by the 166 square miles that you currently live on. Especially, I mean, we're talking to Saif right now. He's in Parma in Italy. So what the future offers is so much more than what existed before. And I just want persons to really think outside of the box and really, think of tomorrow and what can possibly happen. I also want to thank again, on behalf of the Barbados Association of Professional Engineers, Mr. David Lewis and Caribbean Aerial Photography. And just a reminder to those who've joined us, Caribbean Aerial Photography are able to offer the following services to the engineering and other professionals: aerial mapping, 3D rendering, aerial inspections for roofs, bridges, industrial structures such as towers, chimney stacks, etc., progression photography, time-lapse photography, and video. And you can contact David at 264-5617. If you look on the screen, you'll see the email address as well. And that number again is 264-5617. David, thank you for really jumping on board at such short notice. I know that you were keen on this topic, but I didn't realize how very much into this topic you were until today. So Saif, with your permission, I'll forward your contact to David after the meeting, and he'll make contact with you via WhatsApp, and you can go from
please.
there.
Thank you. That's
Fantastic.
very kind of you.
Okay.